In this video, I'm going to go over how I have data acquisition set up on my Diedrich IR-1 lab roaster, which includes a couple of control channels in addition to temperature. This is a 1 kilo roaster with infrared gas burners that has heat transfer characteristics that are extremely similar to my Diedrich IR-12 production roaster. So with a little adjustment to the measurements that I've talked about in a different video, I'm able to use this to decide how I want to roast coffees using less coffee than on the production roaster. One thing that I really like about this roaster is this 5-pin port on the side of the control panel. 2 of the pins are for power and ground, but the other 3 are 0 to 10 volt analog outputs representing bean temperature, fuel setting, and airflow position. Looking at the back of the roaster, we can see on the airflow control a little spring-loaded sensor and a little plate that moves when I adjust the airflow setting. The fuel setting is electronic, but this is a dual pot, so control and data acquisition are kept on separate circuits. One thing to be aware of here is that the minimum fuel setting is not completely off. It's possible to turn the gas off entirely, but an attached data logger isn't going to be able to distinguish between fuel at its minimum setting and a fully off state without some additional modification. If we open up the control panel, we can see where the thermocouple wires come in. One side of this is connected to both the panel display and also to a signal conditioner. That card takes the very small signal from the thermocouple and brings it up to the 0 to 10 volt output that I mentioned before. Connecting all of that to a computer is very easy. There's another box that came with this roaster. I connect the cable from that box to the 5-pin port. That screws in to keep it securely fastened. And there's a USB cable that goes from that box to the computer. If we open this box and take a look inside, we can see that there's a power supply and also a data Q Instruments DI-145. The output pins from the roaster are connected to 3 of the inputs on that DI-145. Now, this device isn't really very good, particularly for those temperature measurements. I've tested a couple of devices like this and found calibration to be poor and the signals are noisy, but to a certain extent it's possible to compensate for that in software, and the hardware is cheap. The last time I checked, these were about $20. To use this with Typica, we need to let the program know how the hardware is set up and how we're using each of the channels. For temperatures, it's really useful if you have a device that can simulate the thermocouple output, as you can disconnect the thermocouple from the signal conditioner, attach that device, and set the output to a couple different temperatures for calibration purposes. There's a set of controls on the right here that can be used to obtain measurements from the DI-145, so you know what to put in the measured lower value and measured upper value fields on the left, and the values that you set your thermocouple simulator to would be the mapped lower value and mapped upper value. So here we can see that when the thermocouple reads a temperature of 100 degrees Fahrenheit, this particular device reads a little over 1/3 of a volt, and at 500 degrees Fahrenheit, it's a little over 2.5 volts. I've indicated that this is a temperature measurement and that I want to hide this channel, and that's because I'm going to later transform these measurements so that they match measurements that I would see on my production roaster. If you don't need to do that, you wouldn't hide this channel, and I covered that transformation in a different video, so I will be skipping that on this one. Next we have the airflow channel. Here I have 3 settings for airflow, but the readings that I get on that are not evenly distributed. So I set a much higher measured lower value to correspond to 0. I'm centering these around the 50-50 setting. On this channel, I only want to see one of 3 values, 0, 50, and 100. So I indicate that this is a closed range, and I set a discrete interval skip of 50. Since I'm not measuring a temperature here, and I shouldn't see any value change when I switch from Fahrenheit to Celsius, I set the measurement type to control, and here again I'm hiding the channel because I don't need to see this on the graph. Instead, I have this set so that when the output changes, the program produces an annotation that matches what I do manually at the production roaster. If we skip over to the value annotation, you can see how I have that set up. The hidden airflow channel is named airflow, and I have a value annotation set up with that as the source column name and the 3 expected values assigned annotations that let me know if I have the airflow control set to through the cooling bin, 50-50, or through the roasting bin. I always want to have an annotation at the start of my batch letting me know what the starting state was, so produce start state annotation is checked. If I pull up the window where I record measurements during roasting, we can see that I have a starting annotation as expected, and if I change the airflow setting, that annotation changes. If I tap Start Batch, you can see that the annotations are time-stamped, and if I move the control fast enough, I can skip directly between CB and RB without logging the brief moment passing through 50-50. Next, we have our fuel setting channel. This is pretty easy to calibrate. Set the fuel setting to minimum, see what is read on the right. On my equipment, I see a slightly negative value here. Then repeat at the maximum fuel setting. I'm looking at this as a percentage, so once again, I indicate that this is a closed range. I don't want to see values below 0% or above 100%. And I found for this, it isn't terribly useful to have fractions of a percent. So I set the discrete interval skip to 1 so that I only see whole numbers. Once again, I'm measuring a control channel, so I set that, and since I'm not going to do any further processing on those measurements, I don't hide this channel. One other nice thing that I have at my lab roaster is this scale. There's a serial port on the back of it, and that is also connected to the computer and set up in Typica, so when I'm entering the details of a batch, I can weigh my coffee, press the print button on the scale, and the weight shows up on the computer where I can just drag and drop that into the appropriate field depending on whether this is a green or roasted weight. I could also have pressed the weigh button on the computer, and that would also pull a new measurement from the scale. I don't have enough space at this roaster to have a laptop placed anywhere that I would be able to look at the screen and pay attention to what's happening in the roaster, so I have a touch screen mounted in front of the drum, so little things like this that can help reduce the need for the on-screen keyboard let me work a little faster.